Hello, everybody. Good to see you today. How are you doing? How is your building going? So today we have Tobias Wohland from Deutsche Telekom, and he will talk to you about building in Hardhat and Foundry. So buckle up. It's going to be fun. And Tobias, over to you.
Hello, everyone. I hope you can see me and you can hear me and you can see my screen. Yep, looks good. Yeah, I'm Tobias. I'm from Deutsche Telekom, and in general, we are building infrastructure for Web3 projects at Deutsche Telekom, but that's not the topic today. Today, we are talking about developing decentralized apps, and we want to do this with Hardhat and Foundry. One thing with regards to questions, a colleague of mine is also here on the YouTube channel, it's in the chat, and he will scan the chat for questions. So if you have any, just shoot them in the chat, and he will forward them to me because I'm not able currently to also check the chat in the meantime. And yeah, I will see if I answer them directly during my presentation or in the end. So what we want to do is, as the overview here suggests, we want to talk about what Hardhat and Foundry are, just very briefly. Then we have a test smart contract I wrote already, and I want to introduce or want to give some overview about this one. And then we want to talk about the setup, the configuration of Hardhat and Foundry. We want to do some basic testing with both tools. We want to deploy our contract to a blockchain, in this case, a local blockchain, a local development environment, local Ethereum testnet. And if there is time, I also want to briefly talk about smart contract verification and also debugging with Foundry, which are, because this is more for beginners, I think. So debugging is a more complex concept, and Foundry is really powerful on that regards. So let's start. What are Hardhat and Foundry? And actually, I just want to stay to the Hardhat documentation here because this sums it up perfectly. Ethereum development environment, and you may already know Hardhat, by the way, depending on your level. And it's all about your helping you during your environment, during the development cycle of your smart contracts, of your decentralized apps. From writing the code of the contract, testing, as mentioned in the overview, deploying, debugging, getting information, useful information about, for example, how much gas your functions in your contract need during execution and so on. By the way, so it's really hard to grasp what the audience is. If you're really new to blockchain, I really recommend when we talk about the contract, we will talk about the concept of gas, and you need to know this. Just as a summary, gas is actually kind of fuel which is needed to run executions, and the user needs to pay for it. That's the very brief overview. In detail, I really recommend this video from Finematics, really cool YouTube channel, and they have a video about gas. It's also maybe shared later in the show notes, so you can check it out if you need more information on that. But now let's getting started. So Hardhat and Foundry. Hardhat itself, and I have a Hardhat project already open here. Actually, I think I will change the font size, at least scale a little bit, because it's very small, and it could be that it's pretty small on the screen. This should be better. So in general, Hardhat is, as you may know or not, it's JavaScript based, and this is why it generally looks, so a project from Hardhat looks like a general JavaScript project, or TypeScript. In this case, I use TypeScript. In comparison to Foundry, which is a tool suite, where you have 4 different tools, and these are all binaries which you install in advance. So for Hardhat, right, it's a Node.js. You use Node.js for managing your packages, and it's all, as I mentioned, JavaScript based. But for Foundry, these are binaries. You install these binaries first, and this is, for example, just in the documentation of the Foundry book. Yeah, it's very, very straightforward. You install them, and then at the end, you will have 4 tools available, which is Forge, Cast, Anvil, and Chisel. The most important tool, I would say, is Forge, which you use for testing, deploying, also gas tracking, and also debugging, and a lot of other concepts. Really powerful tool. Then we have Cast, which abstracts calls to the Ethereum blockchain away from you. So you have much simpler commands. For example, if you would like to get the block number from a RPC node, then you would need to write some curl command like this, right? You write curl, you get the header and everything you need to put in. And with Cast, this is abstracted away from the user or from the developer, and you have very easy commands, which just makes life easier for a developer. Anvil is a Ethereum testnet, which is then deployed locally. This is very similar if you're already familiar with Hardhat, or it is actually very interchangeable with the Hardhat testnet. They use the same accounts and everything is more or less the same. I'm not sure if something is different under the hood, but in general, it's the same. And Chisel is, at least, I mean, I didn't look into this too much, but it is like that you can send Solidity code on the command line to maybe do some brainstorming or something and test something out. So this is at least how I understand Chisel, but I never used it before. So still interesting concept. And then, we have our test smart contract first, and then we want to go over the setup, how to set up Hardhat and Foundry, or Foundry in Hardhat in this case. So we have our contracts folder, and here we have a faucet Solidity file, which is, as the name suggests, a faucet contract. Very basic one where we have some functions. In general, I will not go into detail because it's not about Solidity in this course, but what the contract does is, as the name suggests, you can withdraw Ether from this contract, and the amount of Ether is defined in this withdrawable state variable. And then we have a couple of events and errors. Events are some kind of logging in the traditional development space. And errors, as the name suggests, I mean, these were introduced, I think, in Solidity 0.8. And this is to be more expressive to the user what the error actually was, why the transaction failed, for example. So very useful thing. And I think this is also the recommendation to use these custom errors these days. I also import some dependencies here. I will not go into detail into the reentrancy guard. Maybe at the end, if we have time, maybe you already heard about that. The ownable dependency is a contract which manages the access rights to the contract. If you deploy a smart contract, then this contract is deployed from a specific address, and whether this address or a different address will be the owner of the contract. And you can have restrictions to specific functions where only the owner of the contract can access specific functions. What we have, for example, here, when you remember, you can withdraw Ether with this contract, and you can also update the withdrawable value. Currently, there is of course no default value. It needs to be set in the constructor here. But if you want to update, you need to be the owner. This is the modifier. This is one Solidity concept you may have heard already, where you restrict your function that can be only executed by the owner. And then we have a couple of other functions. Fund faucet, if the faucet runs out of funds, then you want to fund it again. And this can be executed by anyone, of course, not necessarily only by the owner if someone have too much ether. And in the end, we have the main function, the request ether function. And here we see some if clauses where we check for the actual funds of the contract. And if there are not enough funds, you get this custom error reverted or presented, and the transaction reverts. If there's also a time limit, or how many requests you can, no, you can only do X requests, in this case, one request per waiting period, which is 1 minute. And here it is to check whether the waiting period is over, and you can do an request again. And in the end, we send the requested ether to the caller of the function. In this case, if there something else goes wrong, then another check, and we get another more or less arbitrary error message here. And if everything goes good, then we also log something. In this case, we emit an event, the next possible request, so when the user can do the next request. So that's the actual contract. And yep. And now this is what we actually want to deploy and we want to test. And this is where we now come to Hardhat and Foundry. And I always want to do a side-by-side comparison, which I think is pretty handy because they do things differently, but also very similar, especially for these general functionality of testing and deploying. In general, Hardhat, as mentioned again, it's JavaScript based. You have a package.json where you manage all your dependencies. This repository also not only has the Hardhat dependencies, but also some basic linting here with ESLint, and also some formatting stuff with Prettier. By the way, I didn't mention this. The repository is not open sourced yet. It's not available yet, but will be open sourced next week, and everyone can use it later as a template. I know there are a lot of templates out there, but actually when I prepared for the workshop, a lot were outdated. So this is now kind of up to date and can be used. So as again, this will be added to the show notes next week. Yeah, these are the dependencies. And then, as I mentioned, I want to use, or I don't like plain JavaScript. I'm more on the type-safe language side. And here we use TypeScript, and this is where we configure TypeScript. Also not, I don't want to go into detail here. One important thing is that Hardhat is based on CommonJS, on this kind of module CommonJS dialect, and you need to set the module CommonJS here, especially specifically. Otherwise, there will be errors when you have a TypeScript file. Yeah, just that you be aware of that. And then we have the Hardhat config, which we come to in a little bit. But first, as I mentioned, we want to compare Hardhat and Foundry side by side. But first, I need to set up Foundry in the Hardhat project. So we go to the documentation of Hardhat, which is here, where we see we have the integrating with Foundry. Actually, the Hardhat-Foundry plugin is not doing much, just adding Foundry to your Hardhat repository. And basically that's it. And also adding a basic configuration file for Foundry. So, and this is what we want to do. We have two options. We want to add Foundry to a Hardhat project. We can add Hardhat to a Foundry project. We have a Hardhat project and want to add Foundry. Pretty confusing. You need, of course, to have Forge, which is this one specific tool of Foundry installed. I tested this already, so I skipped this. I also have the dependency in the package.json, so we can just install all dependencies, which we can do. There is a now, which we can do here. Of course, I'm not in the repository. And let's install everything. So then we will also have the Hardhat-Foundry tool available or package available. And as next step, we need to import the Hardhat-Foundry package in the Hardhat config itself, because what is very important for Hardhat is that each and every call you do, I mean, each and every time you invoke the Hardhat main function, which is npx hardhat, the config gets called, and if there is something missing, even if you don't need this at the time, it gets an error. So in this case, of course, I would just get an error if I call the init foundry script or functionality, but there are other ways, and we will maybe see it. Did I prepare it? I prepared here when we go over the config files in a couple of minutes. What I mean with that there will be an error, but I will skip this for now. So okay, I added this dependency here, and now we can do the npx hardhat init foundry, and that's what we do. Okay, and let's see what happened. Not much, actually. As I mentioned, it adds a foundry.toml, which is the configuration file for Foundry. And Foundry itself is based on Git modules. So it manages dependencies as Git modules. So to say, as sub-Git repositories within your main Git repository. So we have this Git modules file, which is here. And this points actually to the path where you can find the installation of the repository, which is libforge standard. One thing I don't like about this is that when we see the Foundry toml, we already see, for example, the out folder, and we see the cache path folder. And we see, of course, test folder, which is the same as for Hardhat. So, and there are more folders, which what will happen is that all the folders will be created in the root of the repository. I personally think that's not very clean, because I would like to, because in the end, it's not Hardhat-Foundry, it is Hardhat and or Foundry. So I would really like to distinguish between Hardhat and Foundry also on a folder level. And unfortunately, it's not as easy that I just can create a Foundry folder and just put everything in there. I can put everything in there beside the submodule, because the Git submodule is it's managed differently. It's also added in the Git configuration. There is a .git folder which you don't see here, but there is one, and there is also a Git config there, and there the submodule is added. So this is gets really confusing if you move things manually. So this is why I want to show you how I would do it if I would work with both tools. And there we have a second repository. It's also, okay, because I increased the scale here. It's also plain, nothing is done. So Hardhat-Foundry is not added here. And since Hardhat-Foundry does not much as just adding the submodule, we also want to do this manually. We want to git, unfortunately there is a, hide, git submodule add, and we want to add the Foundry repository, which is over there, Forge standard. This is what the standard library, what we need. We copy this, and then we define where we want to store the submodule, and we want to store it in actually Foundry lib forge -std. And in lib there will be, if you have more dependencies, then you would add more dependencies to lib. This is where there is another another subfolder, and not just forge standard within the Foundry folder. Okay, then let's do this. And again, we just have the Git modules file, and we have then now the Foundry folder and the lib folder and everything in there. And now what we want to do is to create, because we don't have a Foundry config file yet, but I already prepared one. This would take too long if I would do it now. So we will use this one, which is here. Copy paste it over into, this needs to be in the root repository, in the root folder of the repository, I mean. So definitely not, that's not right here. Yeah, definitely not put it into the Foundry folder itself, otherwise this will not work. So yeah, and now we can compare the configuration actually. So I open this, yeah, to the right, and we can compare, and I see I'm still missing the dependencies in this repository.
Tobias, I'm terribly sorry to interrupt you, but
Yeah,
there is a request to zoom in because people can't see what
wait,
well enough to see what you're doing. Guys,
is,
please confirm if it's better or you want Tobias to zoom in more. Does the thumbs up or something like that would work? I think this is good enough. I can
I can
see
also do it
your
one more. I mean, then write it.
perfect.
Okay, do it like that
Perfect.
or like that.
Keep an eye on the comments. They will
Eh,
let you know better. See,
okay,
good. Thank you so
okay.
much. Sorry to interrupt you.
No worries.
Cheers.
Okay, sorry guys, So again, I'm not sure if the zooming, I think it doesn't work on for the terminal, but for the IDE, it works for sure. So yeah, we added the Git submodule. We have the Git modules file. We have added the submodule into the Foundry folder, Foundry lib folder, so to say. And now we have also the Foundry configuration file. And we now also have, of course, the hardhat configuration file. Maybe I can just open a terminal here as well. That should be bigger than as well. Yes, that's, I think, a good idea. That's this one. And yes, so as we can see on the right side, we are still missing the dependencies for hardhat. It's red. Because this is also another new repository, right? Compared to the first one, because I switched repositories. So let's install the dependencies and then go over the configuration. Actually, they are both very similar. We have a Solidity configuration thing. I mean, this is just a basic configuration, right? They offer a lot more options both. But for here, I added so some kind of the similar settings so that we can compare how things are configured. On the hardhat side, and here I think also the handiness of TypeScript comes in, because I define this as a type hardhat user config, and you could look up in the actual code of the hardhat node module what this comprises. So what settings you can do here. But yeah, so as a reference, really handy thing also with TypeScript. I think you don't have this that good in JavaScript. So we have Solidity settings. We set the compiler. We set also the compiler on the Foundry side. And we also set an optimizer. This is also, I think, defaults to true, but I set this explicitly. Sometimes it's also nice to read this. We also set the optimizer here. I will not go into detail what the optimizer does, but basically it, as the name suggests, it optimizes your code on a byte level, on a bytecode level. And the outcome could be, for example, gas savings when your functions are called. So it's very recommended to enable this. And as I mentioned, I think it is enabled by default. Then we have a path section here at the hardhat configuration, and I also have a lot of paths, as you can see here, for Foundry. And this is the difference now. Instead of putting everything in the root directory, we put it into the Foundry folder, which we just created while adding the submodule. And for hardhat, we keep it as it is because that's the, so to say, main project, right? We added Foundry to hardhat. So we could, of course, also create, I think, a hardhat subfolder, but I don't want to make it too complicated for now. We configure a gas reporter. This is also interesting. That's the difference actually between Foundry. So both offer gas reporting, but for Hardhat, you need to configure this here. For Foundry, this is a command line option. We will see this later. But what you configure here is what contracts you actually want to get a gas report for. So a bit different. And also the network settings or the network section is a bit different. While you define more properties for networks like chain ID or even accounts for the networks on the Hardhat side, you just give RPC endpoints on the Foundry side. This is some handy thing actually, which comes with Hardhat, because as you can see, you have this accounts thing, and you can add accounts here. I use a private function or a function here to parse keys from the environment. And I have an environment variable here, which will parse the Sepolia keys. I think we will not make it to deploy to Sepolia as well, but I have it here just in case. And yeah, so you will have the accounts at hand when you write your deployment scripts, your deployment modules. This is how they are called in Hardhat. And you may wonder, if you're not familiar with that, why there is no accounts for localhost. Well, that's because this is already handled under the hood by Hardhat. You will have accounts from the local dev environment available while you are developing your deployment scripts or your testing scripts and so on. So you don't need to care about this, because these are kind of standard accounts, standard private keys, and never use these private keys for a real network. Also, maybe even not for a test network. Yes, and that's actually configuration. You see some differences, but also in general, very similar. And of course, as I mentioned, this is just a basic configuration. There are much, much more options. And now we want to come to the testing. We had our contract, which is in the contracts folder. And now we want to see how tests look like in Hardhat and in Foundry. Again, we have a TypeScript file for Hardhat, which is this one. And I think I didn't have the tests here yet. Yep, I will copy paste them. I prepared them. Let's do this from my already. Yeah, I need both. Sorry, this is still small, but I'm coming back to the bigger, to the zoomed one. Okay, and we have a test here. And we will do the Hardhat tests on the right side. So, well, this is getting a bit confusing because it's so much code. I hope I tried to not go into all the details here. So the first difference is, as you may see, I'm sorry, this is, of course, no, this was right. I want to close this one. The first difference is that you write, as I mentioned, TypeScript for Hardhat, but you write Solidity for Foundry. This is very, very interesting concept, and I like it a lot, actually. And this means when you write your tests and also you write your deployment scripts, you actually access the contract from outside the test environment, or from outside the Ethereum network, whatever network you are deploying to. In the test case, it is a test network. And what I mean from outside, it is like if you want to interact with a contract on the blockchain, right? From outside the blockchain. But for Foundry, it's different, because here you are interacting from inside the EVM, because you're writing Solidity code, and there are some contracts under the hood which are deployed from Foundry when you want to run your tests, and these contracts will then call your deployment scripts and whatever, and will call the function calls you do during your tests. So this is really inside the EVM. That's a major difference, and this leads also to the fact that there are differences is how you retrieve data, how you do your calls, and I will show some examples in a minute. Just as a just to start with the imports here, because we import on both, but of course this is JavaScript, and here we import our Hardhat specific stuff. And for Foundry, we import our Foundry specific dependencies. In this case, it's 3 dependencies. The test.sol contract is the major testing contract. For example, this covers that this includes assert equal, so that all of your contracts, all of your tests in the end have assert equal at hand, and a lot of other stuff. And console2 is there is console.sol and console2.sol. Both offer similar functionality. I'm not sure what the difference exactly is, but in the end, you have console.logs, what you also have at Hardhat side. But this is, of course, not as easy in Solidity. So this is why there is another contract for that. And we have vm.sol, and vm.sol offers you a lot of, they call it, I mean, the Foundry creators call it cheat codes. And maybe that's a really good name, because you really start to cheat and try to, for example, you can influence the blockchain. Okay, there's a question just quickly. How did you get those colored bracket pairs indicator? Oh, okay, yeah, very. Okay, that's not about the course, but just quickly, there is a VS Code extension. I think it's colored something. I'm not sure, parentheses. But there is a VS Code extension for this. I'm not sure which I used. Sorry, I can't find it here. But yeah, just Google for it. You will find it, pretty sure. Yep. Okay. So again, we have these imports, and then all your contracts need to inherit from test. And I write a basic test setup here where we deploy our contract, the faucet contract, and we inherit from test so that all the test functionality is at hand. There are some basic constants which we want to initialize our contract with, and then you have the setup function, which is specific to Foundry, and you need to have this, and you put actually your code into the setup function, and as the name suggests, sets it up. So in this case, it always deploys the contract. And also some kind of cheat code already here visible. This is not Solidity. I mean, payable is a Solidity function, right? Where I can cast an address that it is payable. Make address is that, and as the name suggests, an address is created, an account is created from a string, very handy. And then we just create this account Alice, because Alice should be the owner of our contract, which is in the constructor, and do it like that, sorry, which is in the constructor here. We also set the initial withdraw value, and we also set the initial balance, which is these curly braces syntax where we define what value of Ether we send with our contract. On the Hardhat side, we have something similar, and I make this a bit smaller, a bit bigger now, because it's much better. We have something similar like this faucet setup thing, test setup thing. It is a fixture. They call it load fixture. I mean, the function how to load this is load fixture. And actually what we just do, we create another function now in TypeScript and do the same actually here, what we did on the left side on Foundry, exact the same. And we need to call this fixture before each and every test. And you may ask why you do this like this. Why not write something like before each or before all if you're familiar with TypeScript, which would mean that you execute this function before each test. The thing is that if you do this, then yeah, the function will be executed really before each test. But this could be very time consuming if you have a lot of tests. In this case, it doesn't matter, but in general, if you have multiple contracts, big contracts, they interact with each other and so on, then things get a bit more complicated and it could take a longer time. And load fixture creates some kind of cache, and if it recognizes that there is no change to the actual initial deployment, it will just load the cache, and this is much faster. Yeah, really interesting and cool concept. And then we have our describe blocks, and there in the Foundry documentation there is a section about best practices, and they mentions how to handle your describe blocks, right? A describe block here describes, tests a specific function. In this case, it is the constructor. Here we test the fund faucet function and so on. And then we have separated describe blocks if so, where I test, and this can be done individually, right? Differently. I like the sub-describe blocks, so to say, where I test functionality. I also could test the event image here already, but I do it separately. And then you could test all the events in one describe block, all the functionality in one describe block. And when we go down a little bit, and there's an error, well, we test also the errors in a separate describe block. On the Forge side, as I mentioned, there is a best practice side, and they mention you have two possibilities. One is you write one contract, one test contract for one contract you want to test. In this case, it would be just one contract for the faucet contract. But I decided for the second approach, which I like more, which is that you write a contract for each and every describe block comparable to that, right? I write a contract, I write a constructor contract, I write a fund faucet function contract, and so on. And then you encapsulate all the functionality in these contracts. I don't have subcontracts in the contracts in terms of, because I mentioned here that I use even deeper structure of describe blocks for functionality events and so on. I don't use this here, but I'm not sure if this would work. I don't think so. Not as easy from a structure at least. And then you have your tests, and maybe I want to go on the differences. When I mentioned you call on the right side, Hardhat is calling from outside the EVM, which is what you would expect. But on the Foundry side, you call actually from inside the EVM, and this makes things different. Let's, for example, take the way you get them balance, right? In TypeScript, you would need to here would need to use ethers.js. Ethers is bundled with Hardhat, so you have it at hand at the Hardhat runtime environment, which I imported here. This is the HRE where it is imported here. And then we call the ethers functionality. We call the provider functionality from ethers. We call the get balance function. You get my point, right? It's a big call actually. And there are more of these things which are much more complicated than just do it in Solidity, because if we now compare this, we just call address of our contract and dot balance. That's it. Very easy, very nice. So this is at least some kind of advantage. There's a question. In one test map or divide? The question is, do you prefer to have your test in one test map or divide test into each function map? Do you prefer to have your test in one test map? I'm not sure what you mean with test map. So if I would have multiple contracts, I would also have multiple test files. And as I mentioned, I like this describe approach, so where I would have one contract per describe block. So I'm not sure if this answers your question, but you could also have just one contract and put everything, all the tests with some descriptions. And I think the cool thing is also that you have a NutSpec available here, the Solidity code documentation specification, and you could use this for better structuring if you just use one contract approach. But yeah, that's up to you. I hope this answered your question. because I don't know if you were referring to Foundry or to Hardhat. Maybe you can add this. But yeah, so that's the difference. Yeah, I mentioned that there are differences in terms of how you call things, and there are more differences. I will not go into detail, or maybe later on if we still have time, but I doubt that we have time. So let's actually test now. So I open the terminal, close the code a little bit, and we want to test. And actually, not much to do as just type to test with hardhat. We do npx hardhat test, and in best case, everything runs through and it looks good. All tests pass. One thing, because what I want to mention is because we added the gas reporter configuration in the config, right? Which is, I will close the code for now and open the config again, here, which is here. And I create, as you can see, the output file is in .test gas-report, and then you get a gas report for the function calls of your smart contract, which is really handy. So you get a good understanding how much gas is consumed from your functions. And then you can, of course, start to optimize here. If you're already a pro, then you can use inline assembly, which Solidity supports, or there are maybe even more effective calls of different functions and so on. So really nice to have this feature and not just to deploy it and test the function manually and then see how much gas it consumes. So this is really, really nice. What you also have beside the gas report, of course, because we want to know how much of our code is tested. And there you have the npx hardhat coverage tool. And this gives you an overview, tests again, of course, and then gives you a table how much of your code is covered by your tests and also what is not covered. Really handy and very helpful. I didn't mention this, but maybe we can go to the package JSON, to the setup actually. I don't have plain hardhat as a dependency. I use this hardhat toolbox, and I really recommend to do so for you as well, because this offers a lot of tools which are very helpful. It offers ethers already, the hardhat images. You can read this down. Also, this coverage thing I just used, so very, very helpful. And no, actually, there is no reason why just to use hardhat when you have also the hardhat toolbox. So recommend this. And that's actually how you test your code already with hardhat. And then we can do the same with Foundry. And hope everything goes well. Let's see. And for Foundry, as I mentioned, we have these different tools. We use Forge, and Forge offers a couple of functionality we will just want to test. Okay, that looks good. It's compiling the files and all the tests pass. And as you can see, it's also very fast. And you also get, by the way, a gas estimation, how much gas your test function uses. Not sure where this is exactly helpful because the test function is not deployed, but anyway, nice to have. Maybe there are edge cases where this is very helpful, or maybe I don't see it for now. And you can also create a gas report. And as I mentioned, this is not configured in the configuration, but via a command line argument, which is -- gas report. And then we do the testing again, and we get a gas report, a pretty nice overview table. And that's already it with regards to testing. What I didn't, maybe one more thing, which is really handy and really interesting for both for Hardhat and for Foundry. I will show it on the Hardhat code. You have this network helpers here, which are really, really helpful, as the name suggests. And beside this load fixture function, there are more tools. And one more tool is this time kind of framework or dependency or package, which with which you can actually influence the time of your execution environment. I mean, of your, right, when you start your tests, Hardhat spins up a Ethereum chain on your local host just for these tests. And you can influence the block time or the time in this EVM by using this time library. If you remember, we have this faucet contract and we have the request ether function. And we have the waiting period where we need to wait for 1 minute. And where is it? Yeah, and when I want to test that that I can actually call the function 2 times, but not in a row, I can use this time functionality where I can increase the time, increase the time for whatever time I need. In this case, I take the latest time and then add 70 seconds to this because this exceeds our waiting time, and then the call should wait. If we just uncomment that, we would see that this wouldn't work because we would get, hopefully, an error. Let's do this hardhat test. And yes, this is what we exactly get. We get our custom error, too many requests, because we didn't wait the time period. And you have something similar for Foundry while using one of the cheat codes I mentioned. And there is maybe just as a reference here, if you go to the Foundry book, really, really good documentation, by the way, you have a reference here for all the cheat codes. And if you just look at this list, you see what you can do and what is available. So it's really, really powerful. Okay, for the matter of time, let's come to deployments. And again, I want to compare them side by side. So we have our deployment script for Hardhat and for Foundry. First of all, I think for Hardhat, there is no other way than writing these, they call it modules. So you need to write these modules, and you can create deployments. You can even also interact with your contract if you load it up. If you can also interact with already deployed contracts, you can do a lot of stuff. And this is a very basic deployment script where we just get an account, and I call this initial owner. So this will be the owner of our faucet contract. And then we just build this contract with the constructor arguments. So this is a bit, let's say, counterintuitive, I think, when you need to use arrays and all this stuff. This is better when you write plain Solidity on the Foundry side, definitely. And you hand over the balance you want to fund the contract with. This is done in these curly braces. There it is. And we just return the contract and we export this module, and that's actually the deployment. For Foundry, that's a little bit different. You can do scripts, and I definitely prefer scripts. It's more expressive, and of course, it's also like some kind of documentation because you can use it over and over again. But you could also use the command line if you need to be quick and want to test something, you can use forge create to deploy your contract. And then there are several options. I mean, all of these tools offer a lot of command line options, and this is way too much for here. But yeah, this is what you actually need to find out on your own. But for the contract, for the deployment script, I mean, this is also, again, as you see here, it's also again written in Solidity. It is a contract, also very, very handy again. And here, for example, you also use some kind of these cheat codes I mentioned. In this case, it's this env-uint function, which loads an environment variable from, an environment variable. And yeah, I have here localhost private keys, which I need to inject. Contrary to Hardhat, where you don't need to do this, even not for localhost private keys at least. And of course, this would be only work for localhost, right? If I would need to deploy to Sepolia, I need some more logic here because the private keys for Sepolia are not stored in localhost private keys. At least they shouldn't be. So this is where Hardhat is a bit more handy, I think, when you have these accounts here in the configuration. And for the local test network, as I mentioned, for the local test network, you don't even need to define accounts. So there's another question. I can just jump on that. Which would you recommend to learn first, Hardhat or Foundry? Hard to say. My personal preference would be Foundry. Now I know it because for me, the advantage is that you only write Solidity and you don't need to set up actually a huge JavaScript setup here, which is also sometimes painful. So for me personally, it would be Foundry, but that's a very personal preference. I cannot really recommend from the functionality. Both tools are very. I mean, they do what they are there for. They help you in the whole development cycle of your smart contracts, and both are fine with that. And I mean, since you can have both, maybe you start first with Hardhat, because the integration, as I show here with Foundry, is very easy. And it also depends on your knowledge. If you already know JavaScript and TypeScript, then maybe a Hardhat is easy to go, and you're pretty new to Solidity. It depends. It depends. I hope this helps a little bit, and maybe also the workshop itself helps for deciding on that. So we were at the deployment script for Hardhat, for Foundry, sorry. And we do the same here. We load our private keys. We extract one private key because it is an array, what we get back. And we use another cheat code, which is that we create an address from the private key, which is stored in this array. We make it also payable because that's necessary, since we defined it in our constructor in the contract. And then we have these broadcast cheat codes, which actually broadcast the contract to the EVM, or I mean within the EVM, right? Because it is within the EVM. And that's actually it with regards to the scripts already. And let's deploy this. So what we need to do, and I do this in a separate terminal, I need to spin up one of the test nets. As I mentioned, we have either Hardhat node, which is a local dev environment, or we have Anvil, yes, which is the local dev environment from the from the Foundry side. You see, I mix already things up, and I use Anvil here because it's just Anvil, and that's it. And then we have a private and local deployed Ethereum network, which is exposing stuff to the local host on 8545, which is the general port for RPC interaction. And when we have this, we can start to deploy. And for Hardhat, we just use npx hardhat, and here we use Ignition. So Ignition is another tool which comes with a Hardhat toolbox. And this is, I think, the recommended way how you should deploy your contracts. It's not only that you deploy, and I will show you in a minute what I mean with that. It also manages when you deployed, what you deployed, and so on. So let's deploy first and then go into detail that. And I will take a bit longer, as you see already on the time, but I got permission from Sophia that this is not an issue. So from Chainlink side. Okay, npx hardhat ignition deploy. And we want to deploy where it is. It is in the ignition folder. It's in the modules folder, and we can deploy everything, but I specify it specifically. And then I also say to which network I want to deploy. In this case, it's the local host network. Let's try this. And it is deployed. That's it. So what I mean with that, Ignition manages your deployments. When I want to deploy again, what happens then is actually nothing, because nothing changed and it is already deployed. You see that it is there is a deployments folder in the Ignition folder, I think. Yeah, exactly. And here it manages when you change things and so on. So it recognizes if it needs to be redeployed or not. You can of course force this with minus minus. It's not over reset, I think. But I mean, yeah, then it's get deployed again. But I would do so, of course, on mainnet. But for testing purposes, it's mostly easier to reset. And what I didn't describe, and this goes also a bit too far for the deployment module of the Hardhat. Sorry, that's not Hardhat, that's Hardhat. That it uses these modules, these strings you define here. These are some kind of IDs, and you have this ID for each and every module interaction. And I'm not sure, I don't remember how they call it, but you can actually modify this and be really on a really programmatic way. So it's hard. This is not a yeah, this is not on an introductory level. I think this is a more advanced concept, but really check their documentation out, and I think you will get an idea of what I'm talking about here. I don't go into detail on this thing, but this is also really powerful. And let's deploy a contract. There's another question. I will answer this after the deployment or at the end. Let's deploy with Foundry. So increase the terminal a little bit. And what we want to do is, again, we use Forge to deploy, and we could use Forge create, as I mentioned, on the command line to deploy, but there is another subcommand which is called script, because we are deploying via a script. And then we need the path to the script, which is in this case Foundry script and faucet.sol. If we would have multiple deployment scripts in this one Solidity file, and you want just want to call one, then you would need to define this. I think it's also possible that you can run all the contracts you defined, your deployment contracts or interaction contracts you defined in your script Solidity file over here. So right, I just have this deployment contract, and I close this for now and just have it here. So I just want to use this one. I'm not sure whether I could, let's try it actually, whether I can use without the colon, where I specify which script I want to use, which contract. We also need to set the network here, but here it is set via -rpc URL, and we use just localhost because we had configured already in the configuration, and we need to use the -- broadcast flag or CLI argument broadcast, which means that it gets broadcasted to the blockchain. There is also a dry run feature in Forge or on Foundry, which is really nice. So you do a dry run deployment, which means it wouldn't deploy it. And you get, I think, an output of how it would look like. I'm not sure. I didn't try this out. So, but there is this feature. And okay, yeah, we get a revert. Very nice, because I don't have the local host private keys environment variable. So let's add this quickly. You can just copy paste here. As you remember, we have our Foundry deployment script, and we load this environment variable, hard-coded here, not the best way, as I mentioned. There are definitely better ways. You could also have a contract where you manage which keys you want to load, for example. This would be some idea. But let's add them here to that we can, oh, that's not the right one. Sorry, because I copied from the console. Copy, this doesn't work. And then we add some keys, and we just get the keys from the annual test environment. As you remember, we fired this up here. If we go back, we see our accounts and our private accounts, and I just add 2 here to this end file that one can be used as a deployment or as an owner for the actual contract. So that's it. And then run it again. And yeah, that's it already. We also get actually exactly what we paid for it. That's also really nice. We don't get this out of the box with Hardhat. Not sure if we get this with some configuration. And we get, of course, the address for that. And that's the deployment you have. I missed, by the way, also you have the gas report. No, I added the gas report, or I talked about the gas report for Forge test. And there's also a coverage that the testing or seeing your coverage of your code is also available in Forge via Forge coverage, actually. And then if you're familiar, I'm not doing this now because of time reasons, but of course you could interact with your contract on a script level. So you could write more scripts to interact with the contract test functionality, but sometimes it's nicer and cooler to do things manually and to test things out. This would be like interacting with a real deployed decentralized application. And there, if you don't know, you could use Remix for that, where you can actually just load your you could deploy the contract in Remix itself, but you can also load it when you use this add address feature. As I mentioned, I will not do it here, but I'm pretty sure you already know this tool actually. Remix, everybody knows Remix. Okay. And there was another question, which is, hi, a Hardhat user here. Does Foundry have some functionalities not included in Hardhat? Yes, I'm pretty sure it has. I'm at least aware of one functionality which is very powerful, at least from my knowledge, and I don't know everything. So maybe I missed that on Hardhat. But what you can do is debugging on the EVM level. This is, of course, really pro level. And what would this look like? Let's try this out, which would be Forge test. I think it's minus debug. And then we need to define the function we want to debug. We have our test here. And this is, I'm now debugging a test function, because if I would like to debug the function from the contract itself, I need to pass a lot of stuff, because I need also to pass the constructor arguments in this one CLI command. So it's getting really a big call. So I want to avoid this, and just to show you at least the debugging functionality, I use a test function here. But of course, but this can also help, of course, if there are some specific errors in your tests which you can't find what's going on there. So let's say we want to debug this test, or maybe this one of the constructor test initial balance is set correctly. We add this to the okay. That's not how it should look like. It should work now. We add the test function, the declaration, how it is named. And then, terminal size too small. Okay. Also interesting. I will do it on the other terminal. Let me do it. So it will be pretty small for you guys, but I hope you get the point. So let's do again Forge test minus debug, and then we have the test function. And then what you will see is, the debugger on the EVM level. And what you will see here, if you are familiar with that, these are the opcodes of the EVM. And you could go over each and every instruction and see what is happening on the opcode level, which is really powerful. So here, in the first place, everything is highlighted, which means this is still, I think, the constructor. And I mean, this is really pro level things, right? You need to really know what these opcodes are doing. And I think if you're long enough into development, you also know at least some stuff of this. And at some point we will reach the function itself. And you see there is a lot going on. So this is, I think, something which Hardhat is not capable of. But as I mentioned, I'm not 100% sure. This is one functionality. Beside that, I think for the beginning, they do the same, right? If you start working on smart contracts and want to deploy and test your stuff, do the same. But if you get more familiar with it and go deeper into the rabbit hole, you may see some things which you may not can do with the one tool or with the other tool. I'm pretty sure you will figure it out at the end. Google will help you. ChatGPT will help you. By the way, this is one mention word. Just a second. You will figure this out, and then you will see maybe that the combination of both is really a dream team. I'm not sure, but in the beginning, it's may worth to start with one. And I mentioned if you are familiar to JavaScript, maybe Hardhat is the one. If you're pretty new, maybe Foundry is a better fit because you're just coding Solidity, which is really nice. If you don't need to learn also JavaScript or TypeScript stuff, if you're not familiar to that, yeah. And now I forgot what I wanted to talk about. I'm sorry, I just opened this, but I don't remember when I closed my thought. Sorry, but yeah. That's actually it. I have also maybe just as an addition, which although we are already over the time, I show you the debugging thing. But what is also very important, also if you're new, and also if you are just someone who interacts and with a smart contract or with decentralized applications, very important thing is this smart contract verification, where tools like Etherscan or Sourcify, which is, I think, the tool built by the Solidity guys themselves or by a sub-team of them, where you do a verification of the actual source code and the deployed code, because it can happen that a malicious actor modifies the actual deployed code, so on the bytecode level, and you don't recognize. I'm not sure how this works because I'm not a hacker, but I think there were already some kind of these things, because otherwise the contract verification wouldn't have developed maybe, or maybe to prevent could be also the case, these things. But anyway, it's very helpful so that the contract, the code you have and the deployed code is exactly the same. You will get a check that, and you can do this with Hardhat and also with Forge on the command line during your development. If you have, for example, on Etherscan an API key, you can use this API key and verify your contract also on testnets, of course, not only on mainnet. You can test this out on testnets as well. Very important thing. And also one more thing on that, Etherscan only does partial verification. I think there are some specific data, I don't remember what it was, which is not sent during the verification process to Etherscan, or which is not verified by Etherscan, but Sourcify does a full verification. And I think even there could be some modification of the code on this level. So malicious actors always try to find a way to hack. So yeah, this feature is very, very important for your further journey. And with that being said, I think I'm done. And thanks for being with me. I wish you a lot of fun during the hackathon. And yeah, also a good journey, a nice journey during your Web3 development. I hope maybe some of you is the next guy who develops the next cool Uniswap, whatever Web3 application. And I'm looking forward to that. And thank you very much.
Thank you so much, Tobias. That was brilliant. So, guys, let's say a huge thank you to Tobias, and I'm sure there is a lot to take in. And also, I wanted to add for those of you who are at the beginning of your journey, and since during this hackathon you're building with Chainlink, we have a starter kit with Hardhat. Not that we have preferences, not at all, but you can find a Hardhat starter kit on our GitHub, and feel free to use it. It will save you a lot of time, but of course, you're more than welcome to use any other advanced developer environment. So, Tobias, thanks a lot. And a kind reminder about other workshops that we have today. At 1 o'clock Eastern time, we will have a workshop with Base, and they will tell you how it is like building on Base. At 4 o'clock, also Eastern time, we will meet with Kevin Nielsen from Moonbeam, and we will learn how to build with Moonbeam. And at 6 o'clock, also Eastern time, we will talk about deploying with DApp Launchpad with Veins from Double Club. So I will copy paste a link to the full schedule for today and for the rest of the hackathon here for your convenience. So very well done joining us today. Thank you again, Tobias, and enjoy the rest of your day, you all. Bye.
Bye.